In last class, we derived input impedance of the transmission line. In today's class, we will discuss about the concept of lossless and distortion-less transmission line. Now let us discuss about lossless transmission line and its characteristics. Lossless transmission line. What is meant by lossless transmission line? To know about this one, let us consider a transmission line consisting of two conductors. These are what? Conductors. Conductor. Here also another conductor. Conductor 1, conductor 2, separated by a dielectric medium. This one is dielectric medium. Dielectric medium. If you want to say a transmission line is lossless, these conductors must be perfect. Conductors of the line must be perfect, and the dielectric must be perfect dielectric. Conductor must be perfect. Dielectric must be perfect. What it means? Conductor must be perfect means for perfect conductor, for perfect conductor, conductivity is what? Infinity. R is resistance is what? R equal to 0. R equal to 0. As sigma equal to infinity, R equal to 0. Similarly, for perfect dielectric, sigma should be what? 0. Sigma is 0. Sigma is 0 means what? There is no conductivity. Here it is infinity conductivity, means maximum conductivity. Maximum conductivity means what? We got maximum current. Maximum current means what? Minimum resistance. Minimum resistance means R equal to 0. Here conductivity is minimum. Conductivity is minimum means what? Current is 0. As conductivity is 0, current is 0. As current is 0, conductance is 0. So these are R and G are elements of the transmission line. Now we can define lossless transmission line in terms of R and G. So a transmission line is said to be lossless. A transmission line is said to be lossless. Said to be lossless. What is the condition? If R equal to 0 and G equal to 0. That means for lossless transmission line, R should be equal to 0, G equal to 0. Generally, what is the relationship between R and G? R equal to 1 by G, that is general relation. But for transmission line, R equal to 1 by G means what? R equal to 0, then G should be what? Infinity. That is R equal to 0 means G can be written as what? 1 by R, then that equal to what? G equal to infinity. Or else here G is what? 0. As G equal to 0, R equal to what? 1 by 0, something by 0, that gives what? Infinity. So generally this relation is applicable for lumped elements, but transmission line is what? Distributed element. In this case, R is not equal to 1 by G for transmission line. And for lossless transmission line, R equal to 0, G equal to 0. Now we will see the characteristics of the transmission. Now we will see the characteristics of the lossless transmission line. We will see characteristics one by one. First one is propagation constant. Second one is attenuation constant. Third one is phase shift constant. And fourth one is phase velocity. Fifth one is wavelength. And sixth one is characteristic impedance. Now we will see one by one. First one is what? Propagation constant of lossless transmission line. What is propagation constant? It is represented by gamma. Already we know gamma equal to what? Under root R plus j omega L into G plus j omega C. So for lossless line R equal to 0 and G equal to 0, therefore gamma equal to what? R, this one is 0, 0 plus j omega L, that is j omega L into j omega C. root of j omega L into root of j omega C. G value is 0. Then j into j, that is j square root j square, that is j only, root j square j. Omega into omega square, that is root omega square, can be written as what? Omega. Remaining is what? Root LC. L into C, that is root LC. This is gamma. Means gamma is purely imaginary. Gamma is purely imaginary. But we know that gamma is what? Sum of, but gamma equal to sum of real part alpha, that is attenuation constant, and imaginary part beta, that is phase shift constant. Now we can find this alpha and beta by equating real and imaginary terms. Second one is attenuation constant. Attenuation constant. Attenuation constant is represented as alpha. Alpha is nothing but what? Attenuation constant. What is meant by attenuation? Reduction of the signal strength over a distance. By equating real and imaginary in above equation, by equating real and imaginary of equation of gamma, we will get what? That is alpha plus j beta. Generally alpha plus j beta. Therefore here I am writing here itself alpha plus j beta, which is equivalent to j omega root LC. Since gamma is what? Alpha plus j beta. By equating real and imaginary, what is real? We have only imaginary, means the real term should be 0. That is alpha equal to 0. So this is the attenuation constant for lossless transmission line. Next we will move on to another one, that is what? J beta, which is equivalent to what? Imaginary term, that is j beta equal to j omega root LC. The j cancel, beta equal to omega root LC, which is the third characteristics or third parameter, that is phase shift constant beta. Generally beta is what? 2 pi by lambda. We studied beta as what? 2 pi by lambda. We will discuss about this one later. Basically this relation is helpful to derive the relationship between phase velocity and frequency and wavelength. So beta equal to what? 2 pi by beta is what? Omega root LC. So this is beta, third parameter. Fourth one is phase velocity. Phase velocity. Velocity means it has a units of what? What are the units of velocity? What is the unit of velocity? Meter per second. So it is generally defined as a ratio of angular frequency to the phase shift constant. Ratio of angular frequency to the phase shift constant. The unit of angular frequency we know, radians per second. The unit of beta is what? 2 pi by lambda. 2 pi is angle, that is radian, and the length, wavelength is measured in meters. Radians per meter. Radian cancel. You will get what? Meter per second. So Vp equal to what? Omega by beta. What is omega? Okay, we'll substitute omega, and beta is, put omega as it is. Substitute beta as what? Omega root LC. So that is omega cancel. Vp equal to 1 by, it implies Vp equal to 1 by root LC. Now I will ask one question. What is the unit of 1 by root LC in case of the lossless transmission line? This 1 by root LC indicates what? Phase velocity for lossless line. For phase velocity, what are the units? Meters per second. Meters per second. It is having a units of what? Meters per second. This is fourth parameter. And fifth parameter is what? I am writing this one as characteristic impedance. Characteristic impedance. Characteristic impedance. Characteristic impedance, that is Z0. The Z0 generally is what? Under root R plus j omega L divided by G plus j omega C. This one is 0, this one also 0 for lossless. That is under root j omega L by j omega C. J omega cancel. That is under root L by C. That is characteristic impedance of lossless transmission line. Units are what? Ohms. Units are what? Ohms. Next, we will see another parameter, that is wavelength. Sixth one, wavelength. Lambda equal to what? Here beta is 2 pi by lambda can be written as what? 2 pi by beta. What is beta? Beta is omega root LC. Beta is omega root LC. We can write omega as what? 2 pi f, that is 2 pi. Here it is 2 pi f root LC. 2 pi cancel. Here it is 1 by root LC, 1 by root LC, which is equivalent to what? Vp divided by f, that is Vp is equal to f into lambda. This relation indicates what? Frequency and wavelength are inversely proportional to each other. Phase velocity is what? Velocity of the wave traveling through the transmission line. Basically this velocity is constant. That means signal is traveling with a constant velocity. That velocity is known as what? Phase velocity. As it is constant, here frequency and wavelength are inversely proportional to each other. That is one of the important relation. That means here generally lambda equal to what? Vp by f, or else 1 by f into root LC. 1 by f into root LC. 1 by root LC is equivalent to what? Vp. So this is about the characteristics of the lossless transmission line. Why we required a lossless transmission line? We need to send the information without loss. That's why we require a lossless transmission line. Is it lossless transmission is enough to send the signal? In addition to lossless, we have to send the signal without distortion. That means the phase of the signal must be linear with respect to the variations. Or else with respect to the distance. Distortion-less transmission line. In distortion-less transmission line, the phase is linearly varied with respect to the distance, or else with respect to the frequency, or with respect to the parameter. In case of the distortion-less transmission line, we will see all the characteristics or parameters one by one. First one is propagation constant, that is gamma, r plus j omega l, g plus j omega c. Before observing these characteristics, we need to define the distortion-less transmission line. In lossless transmission line, we defined lossless transmission line as what? A line is said to be lossless if r equal to 0 and g equal to 0. Here we substituted r equal to 0, g equal to 0. That means we have a condition for lossless transmission line. That condition is nothing but what? R equal to 0, g equal to 0. Similar to this, for distortionless transmission also, there is a condition. That condition is given by, for distortionless transmission line, R by L equal to G by C, or else it implies RC equal to LG, or else we can write this as L by R equal to C by G. So this is the condition required for distortionless transmission line. Means a transmission line is said to be distortionless if R by L equal to G by C. This condition should be satisfied, or else this R by L equal to G by C can be written as what? RC, cross multiplication RC equal to LG. RC, Royal Challenge, one of the company, and LG, that is also one of the company. LG company, RC company and code. Now here L by R, C by G, or else we can remember like this: R and L are series element, G and C are the parallel elements. For R duality is G, for L duality is C. We can remember like that. This is the condition for what? Distortionless transmission line. Now we will see one by one. Here we can take R and G as common. It can be written like this. That is, here R is taken as common. Remaining is what? 1 plus j omega L by R. Here G is taken as common. That is G. 1 plus j omega C by G. And combinedly it can be written as, that is, root R into G. L by R. L by R equal to C by G. Here C by G. That means L by R is equal to C by G. That means this C by G can be replaced with what? L by R. We can write this as 1 plus j omega L by R. 1 plus j omega C by G can be replaced with what? L by R. We can write this one like this. This root and this one cancel. Since L by R equal to C by G. C by G. Now simplify this one. That is gamma equal to root Rg. Root, this root, sorry, here we have square and this one is what? Root and square cancel. We can write this root Rg. Remaining is what? 1 plus as root and this square cancel. L by R. This square and this root cancel. We can write this as 1 plus j omega L by R. So here it is not purely imaginary. It is consisting of real part root Rg and remaining imaginary part we have, that is gamma equal to root Rg, that is a real term, and here we can write this as omega root Rg into L by R, which is equivalent to what? That is root Rg omega, this one, that is root G. We can write this as root G. Root R by R can be written as root G by R into L. G by R is what? G by R. G by R. We can write this one like this also. That is, send this one to this side. G by R is nothing but C by L, which is equivalent to root Rg plus omega root G by R. Root G. Send this to this side. That is G by R. G by R is equal to G by R equal to C by L. That is C by L into L, which is equivalent to root Rg plus omega root. This L can be written as what? Root L square. Root L square, or else root L into L. One L cancel. One root L cancel. Remaining is root L into C. So this is about gamma. By equating real and imaginary, what is the real term? That is root Rg. We will get alpha, and imaginary, that is j beta, which is equal to, here also I forgot to write that imaginary term, j omega, j, here also j, I forgot to write j, sorry. Here j omega root LC. So phase shift constant now, that is here this one cancel, beta equal to what? Omega root LC. As beta is same, beta in the for the lossless line like this, remaining parameters are also same. Now we will see one by one. Phase velocity, that is Vp equal to omega by beta. Substitute beta as omega root LC. We got Vp as what? 1 by root LC. That means phase velocity and phase shift constant are same for the distortion-less and lossless transmission lines. Characteristic impedance. Here instead of taking R and G as 0, here we can take R and G as common, R plus j omega L divided by G plus j omega C. Now let us take root R and root G as common. You will get here root R divided by root G. That can be written as what? Root R by G. Here we will get root, that is j omega L by R divided by 1 plus j omega, as G is taken as common, it can be written as what? C by G. L by R equal to C by G. Here L by R equal to C by G. So this one cancel. Remaining Z0 equal to what? Root R by G. Here Z0, in the previous case we got Z0 as what? Root L by C. Here we got root R by G. If you see clearly, what is R by G? R by G. It is R and G, R by G. Here we have condition. I am writing condition like this. That is R by L equal to G by C. What you required? R by G. Send this term to this side. You will get what? L by C. This is equivalent to what? That is root L by C. Finally, we got Z0 is also what? Root L by C. That means for distortionless and lossless transmission line, Z0 is same. Now wavelength is also same. What we can say from this discussion, for lossless and distortionless transmission line, there is a difference in the condition. For lossless transmission line, R equal to 0 and G equal to 0. This is the condition for lossless transmission line. And this is the condition for distortionless transmission line. Characteristics are same except alpha. Alpha equal to 0 for lossless transmission line and alpha equal to root Rg for the distortionless transmission line. Okay. So here R values, if you take R value and G value as 0, this distortionless transmission line may become what? A lossless transmission line. But lossless transmission line may not distortionless transmission line. So this is all about lossless and distortionless transmission line. What we require, what we need of this distortionless and lossless transmission line? Basically, alpha equal to 0 for lossless. That means there is no attenuation. No attenuation means if I write this one, so if I want to send this transmission, if I want to send this information, distortionless means what? Lossless means what? No attenuation. That means same strength. Signal strength is same at the input and output. Then transmission is known as what? Lossless transmission, or else without attenuation transmission. Suppose with attenuation means what? The strength is reduced like this. Hello. So this one is input and this one is output. Strength is somewhat reduced. Amplitude is reduced because of the attenuation. Attenuation means reduction of the signal strength over a distance. Coming to the distortion, here I want to send this one as allo, and here it can be maybe like this, or else it is allo. Here it becomes one way. There is a phase change, means instead of transmitting this first position, signal may start at this position. Means instead of H, O may be appeared here, or else L may be appeared here, E may be appeared here. This type of transmission is known as what? Distorted transmission. In order to get the exact information at the output, we need to send the signal as distortionless signal. So that's why we require distortionless transmission and lossless transmission line. We need lossless and distortionless transmission lines. Thank you.